Welcome to 14.1 Equations of Circles. We first need to begin with what is a circle and understanding where it comes from. Everything is basically going to be based off of a cone. Now, when we dissect a cone perpendicular, at that point, it will become a circle at where those two intersect. So as we can see here, the plane that is intersecting this cone, because it is done perpendicularly, will create a flat area where it is dissected. Now, because it is perpendicular, it will form a perfect circle. As we begin to change the direction in which that plane intersects that cone, we will run into one of four different things. We will run into a circle if it's perpendicular. If there is a slight angle on the dissection, we will run it into an ellipse, or better known as a oval. We can also run into a parabola. Now, the parabola itself, remember, is a rounded shape from one side to the other. Right? Whether it's going in a positive direction or a negative direction, keep in mind, it is still a rounded shape. This is different from a hyperbola, where it has a much more straight line, and then it turns into a slight bend exactly at the bottom or top of its curve. Now, as we start to look at a circle itself, the circle itself has a specific formula that we will be looking at, and that is that equation there of r squared is equal to x minus h squared plus y minus k squared. Now, within these different circles, we are going to run into certain things that will remain the same. We will always have a center point that everything will relate to. From the center to the outside portion of our circle, this is called the radius. Now, if there is a straight line that goes from one side of the circle towards the other side of the circle while still cutting through the center, this would be considered our diameter. The diameter is exactly twice the radius. As we take a look at our equation itself, it is extremely important to understand where all of these points and all of these values are coming from. Let's first begin with the h and k. Your h and k is actually going to be the center of your circle. So that would be this location right in here. We're also going to take a look at x and y. Now, an x and y is a point that is on the circle itself. This point can happen anywhere within the circle. This can happen there, here, here, there, or there. At the end, the radius will always be the same throughout the entire circle. And that's exactly what the r stands for. The r stands for the radius. And that is this measure right in here. Now, in the equation itself, we are solving for r squared. If you are trying to isolate the actual value of r, one of the easiest ways is to rewrite the equation in a way that makes it most beneficial, which would be to grab the square root of both sides. So we're still going to deal with the exact same equation of x minus h squared plus y minus k squared. But we are going to get the square root of that entire equation. By doing that, we are then able to solve specifically just for r and nothing else. So let's begin with finding the center and the radius of an equation. We're going to begin with taking a look at our first equation. Remember, our center is always going to be our h and k, and the radius, which originally stems from r squared, we are going to get the square root of our r squared in order to find the r. So let's go ahead and take a look at these problems. In our original equation, remember, our equation had our h and k being separated, which means if we write this over again, this would be x minus h squared plus y minus k squared is equal to r squared. That is our original equation. If you notice, there are always going to be a minus h and minus k. So in order to find our h and k, we take a look at our h and our k. Our h in this case would be 3. Now our k in this case, remember, we are switching this to a minus of a negative 1. So our y of our center would be negative 1. For the radius, we're going to take a look at the outside number to the right of the equal sign, and we're going to get the square root of that number. So the square root of 16 would give us 4 for the radius. We're going to repeat this process with each one of these equations. Second equation, our center would be negative 5, 2, and we would have the square root of 15 as our radius. Because 15 is not a perfect square, it would not be able to break down. We go on ahead to the third equation. Here we see that x is squared. It does not have a plus or minus any type of number, which means this could also be seen as x minus 0 squared. So our center would be 0, positive 2. Now in this case, we don't have a number to the right side of our equal sign, but we do have a minus 9 to the left. We're going to add 9 to both sides. And when we do, we're going to still grab the square root of both sides. The square root of 9 is 3 for the radius. Our last step is going to be grabbing the center for the fourth question, which would be 6, negative 3. Now remember, our equation is r squared. So if we're just looking for the radius, our radius here would be 25. Be extremely careful not to try to do the square root of 25, because a person can become very traditional in the method of we grab the square root of our r squared, but we actually have a square here. So the square root will cancel with the square, and we're left with 25. Now, as we're given a problem to work with, the first two things that we should always find are the center and the radius. In this case, the center for this problem would be 3, 2, and the radius would be 3. First thing we're going to do is find our 3, 2, and plot our point. Keep in mind the radius is 3, and the radius describes from the center point to the outside point. So we're going to move 3 in all directions, which means we would move 3 to the right, 3 to the left, 3 up, and 3 down. We would then connect the dots. In this case, we would just go ahead connect all of the dots from our circle. In this case, once we have done that, we're going to go ahead and move the circle into its place. And we have our equation graphed. Now for this equation, we are still looking at something very similar to what we've done, but we want to keep something in mind. We always want to go ahead and divide if there is a greatest common factor amongst all three of our terms. In this case, we're actually going to go ahead and divide all three terms by 3. Doing this will give us a new equation of x minus 4 squared plus y squared is equal to 18. Once again, we still determine our center from our h and k. In this case, it's going to be 4, 0. And in this case, we're going to get the square root of 18 for the radius, which would be the square root of 18. We're going to repeat the same process we did before. Start off with our center. And we're going to go the distance of square root of 18 in all directions to find the radius, or to find the outside circle using the radius. Now, many people would want to simplify here and try to break down 18 into 9 and 2. That means 3 square root of 2. What I would generally suggest to find the most accurate answer would be to find 2 perfect squares that would make this square root of 18 be surrounded. What does that mean? That means that with the square root of 18, there are 2 numbers we would look at. Square root of 16, which would give us 4, and the square root of 25, which would give us 5. Notice the square root of 18 would actually fall much closer to 16 than to 25, which means that our answer would be a 4-point something number. So that's the number that we're going to use to find our next point. So we're going to go towards the 8, and we're going to stay slightly outside of the 8. The same thing would happen with going towards the left, going up, and going down. Once ahead, again, you would draw the circle. And when you do, you go ahead and make sure that it is as accurate as possible. Now, we don't want to fall directly onto the 8 on the x-axis or the 0 because of the pure fact that, remember, our number is larger than 4. If it was 4, we would be looking at the square root of 16. But because it's the square root of 18, we have to make sure that we're drawing this accurately and that the radius is slightly larger than 4. Let's go ahead and take a look at slide 8. Here it says, write the equation of the circle with the given center and radius. So here we are working our way backwards. We are still going to work with the same equation we did before, which was x minus h squared plus y minus k squared is equal to r squared. Remember, our center is the h and k, which means that for this first problem, we are looking at x minus 3 squared plus y minus a negative 2. Now, when we minus a negative 2, keep in mind this would turn into a positive 2 squared is equal to our radius squared. So 4 squared would be 16. That right there would be our equation for this first problem. Let's continue to work our way through these other problems. We have x plus 4 squared plus y plus 1 squared is equal to 1. Our next center is at 0, 0, which means we can write this in one of two ways. We could write this as x squared plus y squared is equal to 6, or we can write this as x minus 0 squared plus y minus 0 squared is equal to 6. Either of these two equations are perfectly fine and are accurate. Our last question is the center being at 0, negative 2, which means x minus 0 squared plus y plus 2 squared is equal to 1/4. Now, something to keep in mind is that when we're working with a fraction and we're getting 1/2 to the second power, we are actually looking at 1 squared over 2 squared, which is 1/4. Now, this can also be written as x squared plus y plus 2 squared is equal to 1/4. On slide 9, we go over the distance formula and we go over the midpoint. Now remember, the midpoint is just finding the average between 2 points that you currently have. Because you are working still with a point, you add both x values and divide by 2, the same way that you would add both y values and divide by 2. Our distance formula is very similar to the equation that we were working with before for a circle, when we did r is equal to the square root of x minus h squared plus y minus k squared. Now, it is extremely important to be able to understand what it is that we are going to be looking for within each one of these equations. So first thing is understanding we are looking for the equation that makes this circle. Now, there are two things that you need in order to solve the equation. You need the center and you need the radius. If they are both provided within the problem, then it's just a matter of creating the equation. But you could be possibly missing one or even both of these two things necessary for the equation, in which case you will need to find it on your own. In this problem, it says the endpoints of a diameter are 3, 2, and 5, negative 4. Keep in mind, here they're giving you the diameter, they're not giving you the radius, and you are still having to find the center of the problem. You will need to find the distance between the radius and one of those endpoints at the same time. So let's begin with finding the center. What you're going to do is you're going to add your x values, so 3 plus 5, and you're going to divide by 2, and you're going to add 2 plus negative 4 and divide by 2. Once you've done this, this is going to give you 8 divided by 2, negative 2 divided by 2, which is 4 and negative 1 as our center. Now, in order for us to find the distance, we're going to go ahead and use the radius equation that we were using before. Keep in mind, we already have the value of our center, so we're able to plug that in. You can choose any one of the points that you already have. You can use your first point or your second point. I'm going to go ahead and use our first point. So we're going to have r squared is equal to x minus h squared plus y minus k squared as our equation. Remember, we're going to need the square root of both sides to just isolate for r. So r is equal to, remember, this is your x, this is your y. This would be 3 minus 4 squared plus 2 minus a negative 1, which is adding 1 squared. And we're going to look at the square root of this entire problem. So r would be equal to negative 1 squared plus 3 squared, 1 plus 9 would give us the square root of 10 as our radius. Keep in mind, the original equation was always asking for r squared, which means this would provide us a little bit closer to our equation. Our equation would be x minus 4 squared plus y plus 1 squared is equal to 10. And that would be our equation. Let's take a look at B. For B, notice they're giving us the center and they're giving us the point, but they're not giving us the radius. So we're going to go ahead, use this point and use the center to our advantage. And we're going to go ahead and plug it directly into our radius equation. The radius is equal to negative 4 minus 2 squared plus 5 plus 3 squared, and you're going to get the square root of both sides. This will leave you with negative 6 squared plus 8 squared. This would be the square root of 36 plus 64. Your radius is the square root of 100, which is equal to 10. Keep in mind, our equation would be x minus 2 squared plus y plus 3 squared is equal to 100. Remember, the radius was 10. We're going to do the square of that 10, which is 100. Let's take a look at our last problem. Here we have 2 points. We have P and Q. We are looking for the center as well as the radius. Center here would be 1 plus 5 divided by 2, 6 divided by 2, which is 3. Now for the y, we have 8 plus 6 divided by 2, 14 divided by 2, which is 7. So 3, 7 would be our center, or our h and k. We're going to go ahead and find the radius. So the radius is equal to 5 minus 3 squared plus 6 minus 7. And that would also be squared. We will be looking for the square root of that entire side. So r is equal to 2 squared plus negative 1 squared. R is equal to the square root of 4 plus 1, which is equal to the square root of 5. Our equation here would be x minus 3 squared plus y minus 7 squared is equal to 5. On our next slide, we're taking a look at both the general and the standard form of our equation. To get a better understanding of what the standard form and general form are, the standard form compresses all of our terms together to be within squares, while the general form breaks everything out into individual terms and is set completely equal to 0. So our first step that we're going to take is to group all of the like terms. In this case, we have x and x. So we're going to go ahead, x squared plus 4x. We're going to group together the y's, which is y squared minus 6y. And we're going to bring over the negative 3 to the right-hand side, so we're going to add 3 to both sides. Once we get to this point, we are going to find the number that will make this a completed square. In order for you to do that, you're going to need the equation of b divided by 2 squared. That is completing the square. So here for x we have 4, so 4 divided by 2 is 2. 2 squared is 4. We're going to repeat that for y. Negative 6 divided by 2 is negative 3. Negative 3 squared is a positive 9. Now every time that we do completing the square, whatever you add to the left, you are going to have to add to the right side as well. So we did add 4 and we did add 9. You're going to break apart these factors, or these polynomials, into factors. This would be x plus 2, x plus 2. This would be y minus 3, y minus 3. And whenever you have numbers that are together, you are going to just combine them together. So we have 3 plus 4 is 7. 7 plus 9 is 16. From here, you simplify each problem. X plus 2 squared plus y minus 3 squared is equal to 16. And that would be our final answer. Slide 12 goes over the step-by-step of completing this style problem. Now, let's work on 13 together. First thing is, group our variables. We have our x squared minus 8x. We have y squared, which is alone, and we are going to subtract 7 from both sides. We're first going to begin with completing the square. Negative 8 divided by 2 is a negative 4. Negative 4 squared is 16. We're going to break this apart into x minus 4 and x minus 4, which is the same as x minus 4 squared. Y squared would remain the same. So plus y squared. And that would be equal to 7 plus the 16 that we had from the completing of the square, which would leave us with 23. Correction. When we moved over the 7, this would actually turn into a negative 7. Negative 7 and 16 would give us a positive 9. From here, we're going to find the center and find the radius. Our center for this problem would be 4, 0. Our radius would be 3. Let's take a look at the next problem. We're going to complete the problem the exact same way. We have x squared plus 4x. We have y squared negative 6y. And we're going to move over the 3 to the right-hand side. 4 divided by 2 is 2. Squared would be 4. So the fact that we're adding 4, we're going to add 4 to the right-hand side as well. We have negative 6 divided by 2 is negative 3. Squared is positive 9. So we're going to add 9 as well. Here, this will leave you with x plus 2, or x plus 2 squared. Your y's would be minus 3's. So y minus 3 squared. And then that would be equal, 3 plus 4 is 7. 7 and 9 would give us 16. Our center for this problem would be equal to negative 2, 3. And our radius would be equal to 4. What makes this problem different than slide 15 is that slide 15 has all of our variables to the right-hand side of our equal sign. In order to make this work, we would need to then move over all of our terms to the left-hand side, which would look something similar to x squared plus y squared plus 24x plus 6y plus 137 is equal to 0. You group them according to their variables or move it over depending on whether we're working with an individual number. We have x squared plus 24x. 24x divided by 2 is 12. 12 squared is 144. Y, we have y squared plus 6y. 6 divided by 2 is 3. 3 squared is a positive 9. Our last number is the 137, which would go over to the right-hand side and give you negative 137. Now, keep in mind, 137, we are going to add the 144 from the left-hand side, and we're also going to add the 9 from the right-hand side of our y's. We're going to break apart the equation, x plus 12, which is x plus 12 squared. For y, we have y plus 3, which is y plus 3 squared. Negative 137 and 144 is a positive 7. Positive 7 and 9 is 26. So this right here would be our equation. Now from here we figure out the center. The center would be -12, -3, and our radius would be equal to hold on, let me do my math one last time. 137 and 144, that's a difference of 7. 7 and 9 is 16, not 26. Radius would be the square root of 16, which is 4. Our last slide would be slide 16. In slide 16, we are working the opposite direction and working from a standard form and going towards general, which means we are going to break apart these squares. This would give us x minus 4 and x minus 4, which is x squared minus 8x plus 16. We have y plus 3 times y plus 3, which is y squared plus 6y plus 9. Keep in mind we are trying to make the entire equation equal to 0, which means we're going to subtract 36 from both sides. Now, because of the problem that we're working with and we're going from standard to general, we're also going to need to combine our like terms from this problem. So we go ahead and start off by placing them in the correct order. We would start with standard form, which is the highest exponent first. We have x squared plus y squared minus 8x plus 6y. Now, we have 16 plus 9 is 25. 25 minus 36 is a negative 11. And that is going to equal 0. If you have any questions about this PowerPoint, feel free to ask at any point.